Alrighty. Um, I didn't realize that I didn't have a video for modified U sub, so we're gonna do that. Um, like the lesson says, sometimes U sub might work, but sometimes U sub might not work. In other words, you still have an X, but you could play around with the U so that you could figure out what X is in terms of U. Now, for number one here, I'm going to use U sub, and for number two, I'm going to use U sub. But TBH, that's not my preferred method of doing number one and number two, and you'll see why whenever we finish one and two here. Remember how I told you that 99% of the time that U is going to be the denominator, and that's still going to be the case here. So we have x minus 1 over u du. Now this is where our problem comes in with modified U sub, or traditional U sub here. With traditional U sub, I still have an x here, which, not good. But you do know that u is equal to x plus 1. So I'm going to let x be the same thing as u minus 1, which means I could change this. So that's the integral from u of u minus 1 over u du, which gives me the integral of u minus 2 over u du. And then what you guys are going to do here is just go ahead and split this up into two parts because it is one term in the denominator. So you have 1 minus 2 over u du. And then if you integrate this, you will get u minus 2 ln of absolute value of u plus c. Remember that everything needs to be in terms of x now. So you're going to have x plus 1 minus 2 ln of x plus 1 plus c. Now, just a little word of advice, just in case this pops up on the MCQ here. You might not see this answer. Instead, you might see x minus 2 ln of absolute value of x plus 1 plus c, without the plus 1. Now remember that that plus 1 gets absorbed with this plus c. So any constants you have, that's just going to be a plus c because we just don't know what the constant is. So in this case, your answer, your other answer that's also correct, is going to be this right here. All right, same thing with number 2 here, where I'm going to use u sub and let u be x plus 1. And I'm going to have du be 1 dx, which means that plot twist, once again, I have x in the numerator. Not good. Okay, so that means that x is going to be u minus 1, just like we did in number 1, except this time, whenever I sub n, you'll notice that I will have u minus 1 squared plus 1 over u du. Now, what's going to happen here is that I have to do u squared minus 2u plus 1 over u du, which becomes u minus 2 plus 2 over u du. And then if I were to take the antiderivative of that, I get this lovely thing, which then becomes 1/2 x plus 1 squared minus 2 x plus 1 plus 2 ln of x plus 1 plus c. All right. Now, you might be thinking, oh my god, that's a lot. And I'm going to be honest, yes, that is a lot. Like I said, U sub is not my preferred choice of solving these two problems. I am going to have to use U sub no matter what for number 3 and number 4. But anytime you see a fraction like this, like number 1 and number 2, most likely if you could simplify that fraction by dividing, then please divide first. So here's what we're going to do with number 1 and number 2. We're going to redo number 1 and number 2 so that we are going to use long division, or synthetic in this case, because I like synthetic more. We're going to use synthetic division, and we're going to see how that answer and that work is equivalent to our work in terms of U sub here. Now remember that the name of this game is to essentially figure out what is the most efficient method in terms of solving these problems. You have approximately 2 minutes per inactive problem and 3 minutes per active problem. And I'm not trying to waste my time doing U sub here if I don't have to. Instead, I'm going to use synthetic division here. I'm going to have -1 in my little house. I have 1 and -1. That becomes 1, -1, -2. So then if this is still in terms of x, I have x minus 2 over x plus 1 as my integral. So essentially, I'm just rewriting my integrand so that it is nicer. That way, we could take the antiderivative of this and call it a day. Now you might be thinking, oh my Buddha, Mr. K, they look different. Actually, just kidding. Why did I do that? This should be a 1. Oops. That's why. So you should be second guessing yourself. There we go. So that's your final answer. And notice how that is equivalent to what we had earlier, but much, much, much simpler. Wait until we see number 2 here, and we're going to see that this right here looks like a hot mess, but we actually have a simpler version of this right here. So for number 2, I'm going to use synthetic division again. And we're going to look at -1, 1, 0 as my placeholder for x. 1, 2 is my remainder. So now I have the integral from okay, Jesus, I did it again. X minus 1 plus 2 over x plus 1 dx. So then we get 1/2 x squared minus x plus 2 ln of x plus 1 plus c. And you're thinking, how the heck does this right here, which only has 1, 2, 3, 4 terms, is the same thing as this right here? I know. Crazy. Now, I'm going to expand this so that we can understand what's happening here in terms of expanding this. And we're going to see that once we expand this, we can cancel some stuff out. In terms of my simplification. In other words, this 1/2, this -2 gets absorbed with the plus c, so I don't need her anymore. And then this x and this -2x becomes a -x. So we have 1/2 x squared minus x plus 2 ln of x plus 1 plus c. Very interesting how this thing right here that we did with U sub, it's so an answer and so correct, but notice how this here is the same thing as this. And we only did like 2-3 steps. So anytime you have a fraction, and if you could simplify it, simplify her. Now to figure out if you could simplify her, your numerator must have a degree that is larger or greater than or equal to the denominator. So in this case, notice how this one was 1 and 1, so I could have used division there. This one here, we had 2 and 1, so that's great. Now, if we have something like this right here, we don't have a method to solve that yet as of right now, where if your denominator is greater, but later on, whenever we do unit 5, we might talk about inverse trig. And then later on in BC, we'll talk about partial fraction decomposition, if that is possible. All right, so number 3 and number 4 are very similar, so I'm just going to do 4 because that's the harder one in terms of the problem. For number 4, once again, you're trying to look at what should your u be, and like I said, 99% of the time, it's always going to be the denominator, or it's always going to be whatever the argument is. So in this case, your argument is 1 plus x squared. We get that to be our du, which means that dx is going to be the reciprocal of that, right there. So then we get 1 over 2x, the integral of x to the 5th root u du. Now that x does cancel out, but it doesn't cancel out the whole thing. It only cancels out one of the x's. So we're left with x to the 4th. I know, sad. Well, plot twist. X squared is the same thing as u minus 1. So then I could take I could sub n x squared, and I get u minus 1 squared root u du. Now, this is going to get very messy because I have to expand u minus 1, and then I have to multiply that by u to the 1/2. So now I'm going to get u squared minus 2u plus 1, and then u to the 1/2. U to the 1/2 du 1/2 the integral of u, let's see, that's 4, so that's 5 over 2 minus 2u 3 over 2 plus u to the 1/2 du. I haven't even taken the antiderivative yet. That was just me simplifying all of that. Like, that's crazy. All right, so then you get 1/2, and then we are going to, okay, let me do that like here. All right, so now we have 1/2, and then we're gonna integrate her. She's gonna be a mess. So we get u to the 7/2, which becomes 2 7s here, minus u to the 5/2, which becomes a 2/5. But then because I have a 2, that's going to be a 4/5. And then 3 over 2, which becomes a 2/3. So we get all of that. Now, theoretically, if you want to multiply that 1/2 with everything, I guess you could do it. So then you'll get 1/7 u to 7 over 2 minus 2/5 u to 5 over 2 plus 1/3 u to the 3 over 2 plus c. And then u was 1 plus x squared. So if I did my math correct, I don't have my enter key on me right now, so hopefully this is correct. We get this mess right here. I know. That right there. Let me check if this is correct or not. She looks right. I don't know. 1/3 minus 2/5, 1/7. Yeah, she's right. So you're good right there. Now the only one that we haven't done is 3, but 3 is just an easier version of 4, like I said. So you do that. TLDR for this part of the lesson is, if you can divide, please divide. If you can't, then you just gotta suck it up and do modified U sub.